Good morning. We are here live. You have myself, Dani Kurczynski, of course, Dr. Elvira Rakova,
Good evening, everyone in Europe who is having a cup of tea before going home.
Yes, we're on all different time zones. So I'm very excited to have Flavio here from C&CA. And you're in California, so you're even earlier than me. It's 10:30 here.
Correct.
So we're covering all the bases today.
Compressed air connects people.
Yes, it does. And lots of things. Everything is made pretty much with compressed air.
Yes.
So here we go. So I don't want to take up too much time because we're going to try to stick to our 20 minutes. But if it's going really good, maybe we can go a tiny bit over because leaks are a big deal. And I know a lot of customers focus on this first, just because I think the demand side is so overwhelming. So this is kind of something they can wrap their head around. So I really want to let you introduce yourself and your experience in doing the leak detection after your intro and what you do fully, and then we'll narrow it down to the leak detection.
Awesome. Thank you, Danny, and Dr. Elvira for having me here. It's definitely a pleasure. Glad everybody could join us for this. So, my name is Flavio. I am the president of Critical Systems Advisors and Services, also known as CSA, and bring 21 years of compressed air and manufacturing experiences to what we do. So yes, as Danny stated earlier, we are based in California, which is also the second largest utility rate state following Hawaii. And at CSA, what we specialize in is helping manufacturers achieve energy efficiencies, reliability, sustainability, and minimizing their carbon footprint. And we do so through various services like leak detection and repair. The repairs are very important. It's various audits. We do system optimization and a lot more uh, services, in addition to working with local utility companies to provide energy rebates for the clients that do take on our programs.
Perfect. So I want to add this image to the stage because there's some interesting data on here. So what is your experience with this?
Yes, so I'm glad you asked that question. Recently read an article that was published by the Department of Energy, and the article or DOE stated that up to 50% of compressed air makes it to the production area. So the rest of the 50% is either lost to air leaks or improper / inefficient uses. So that's a little bit alarming because a lot of energy is wasted. But the other portion that the DOE stated was that only 30% of the energy used to compress air is actually used for compressing air for manufacturing. The rest is lost to heat and other things that play into it. So seeing that is very alarming because that leaves a lot of money on the table for the manufacturers, and it's a lot of loss in profits, but it also affects their entire production as well. And if you don't mind me sharing a little bit about air leaks and how they work, if that's okay with you.
Yeah, of course.
Okay, so air leaks, most people believe that an air leak is just air coming out of or blowing out of a pipe. So that's true, but that's only partial true. What happens is when you have air that is flowing through a pipe at minimum 100 psi, so we'll call it, for conversation's sake, given the audience we have, we'll call it 100 miles an hour in a way. It's flowing through the pipe. At the same time, it is leaking out of the side of the pipe, or the leaking, whatever is leaking within the system. As air is leaking out, because it is flowing at minimum 100 psi, it's also creating a vacuum. So anything that's in the air, depending on the environment, so if you're a wood manufacturer, the sawdust, all the anything that's in the environment, that gets sucked in at the same time as it's leaking out. And that air that's being contaminated, vapors, particles, dust, rust, whatever is in there, as it's getting sucked in, ends up within the process equipment, which that creates all sorts of havoc as well. So malfunction cylinders, valves that aren't working properly. But then if you don't have the proper protection, which was awesome with the KSI conversation you guys had, if you don't have the proper protection at the point of use, that will end up on the product. So the recalls come in, product rejects as well. So it is important to know what the leaks are doing, because at the end of the day, it's not just costing you money in energy or efficiency, it's actually affecting your entire process. And for manufacturers, they don't realize, that's why they call it the silent thief, that they're literally losing thousands to hundreds of thousands of dollars a year in profit, because a lot of times you get the compressor guys that want to fix the compressors and it's causing problems when the problems are within the process itself. And that usually happens from the compressed air. And I like to mention that it's not just compressed air leaks, it's also vacuum leaks, various gases as well. So all these play a role into the efficiency.
Interesting. I actually had a question that I'm sure other people do as well. Is there a certain industry or process that you have found that is more prone to leaks than others?
No. In fact,
Okay.
they all leak just as bad, because there's not a lot of education to
Mm,
manufacturers how compressed air works. So we see it where regular operators don't believe they're getting the amount of air needed. And that could
mm,
be quantified in different ways. So they increase the pressure. What's not realized is when you increase the pressure in a system, you're reducing the flow because you're choking it. It's equivalent to going to any fast food restaurant, you want to get a soda to drink, and you're going to get a coffee straw. It's going to take a lot of effort, and you're putting in a lot. You're stressing your body quite a bit to drink soda through a coffee straw. As you know, it's got those two
mm.
little holes on it. So that's
Yeah.
what happens when you increase the pressure. When you reduce the pressure and allow for more flow, it's like drinking through a Slurpee straw. It's too much. You can't handle it.
Mm,
So there has to be the fine balance, which is the regular, if we could use the soda analogy, when you're
mm.
using a regular straw, it gives you the perfect flow. You get the right amount of pressure and suction of the drink, and you're not choking yourself or putting stress. So that's how pressure and flow works a lot of times. We find that, I would say, if we were to quantify the industry, food and beverage is at the top of the violators and air leaks. And then we trickle down to general manufacturing. That could be anywhere from packaging, blow molding, any sort of manufacturing. Biopharma, not so much. The challenges with biopharma is air quality. So that
Mm.
way it's quantifying how clean the air is to meet certain ISO standards or FDA standards. So that's because they use stainless steel. So you don't get a lot of leaks through the stainless steel systems.
Okay. Interesting. Elvira, I'd like to get your take on that, like in
Oh
your
yeah,
experience as well.
I'm gonna play devil advocate here. I'm very sorry, no, but I'm joking. But let's make the discussion more spicy. Flavio, the thing that what I saw in the food and beverage. So I did some years ago. I did research on the valve for wine filling machine. It was we need to have a separate coffee and compressed air on the wine filling because it was a lot of fun.
Yes.
I was standing in the pool of wine while they were changing the drinks. So, but
Wow.
they while we measured the consumptions there, and then the consumption was 20% more than the model one than the supposed to be. And when I spoke with the engineers, they told me that they do cause leaks on purpose on their components. So the dust will not come in. So that while it's blowing, it's kind of like blows out all the dust in the environment. And I was like thinking, interesting. So it makes, for my head, I believed them because I was in an uncomfortable situation sitting in the wine pool. But they said that it was 20% for each component of the entire flow that was going, that it was on purpose, the components, the parts of the valve, they were not sealed in perfect way, so that the
Mm.
air would go out and the no particles will come in. But for me, it was a question: why there is no air, the particles still come in, right?
Yeah.
I don't know,
So
Flavio, what is your take on this? Let's let's destroy the ideas of food and beverage industry in those companies.
No, and it's true. You are 100% correct. We get that a
Okay.
lot. A lot of manufacturers believe that they do need to have leaks in order for the system to perform better or to clean the environment. And there are
Mm-hmm.
a lot of other ways to address that without creating such strain on your compressed air. Because as you guys know, compressed air is the fourth utility. It is the most well, one of the most expensive assets to operate within your facility. So there are a lot of efficient ways to prevent that without having leaks.
Okay, we'll call them tomorrow and tell them about this. So I'll find the number because I was really surprised. I said, yeah, it makes kind of like sense, but because they were suppliers of the machines, so they're companies that actually don't pay the energy bill, but their
Yeah.
clients pay energy bill. They said this, it makes sense to have unperfect components. so there are also no leaks and better performance. I think we need to disrupt this belief in general in our future work.
I
I
agree.
think, yeah, I think whoever their marketing person is did a really good job selling that idea.
It's a very good job. It was about 5 or 10 years ago, but I still heard those beliefs actually from
Yeah.
few
Yeah.
companies. And to
Mhm.
all our listeners, and we're going to do the post and campaign for that. I think we should make a campaign like no leaks in
Yes.
components. It's a full truth. So let's fight it for the sake of compressed air and for the end users.
Yes. Yeah. And there
Wow.
are processes that have where they have to allow some bleed off, we call it. So there are processes that do allow for that, but again, it's controlled and it's not a
Mhm.
lot of air bleeds and it's not just blowing into thin air. Because again, you may be to use your client's thought process, it cleans the environment. Well, not necessarily because you're blowing the air, it might be clean right at the source, but what if the air is contaminated? Now you're actually contaminating your product. At the same time, if you're blowing it out into thin air, you're spreading it all around. So are you
Mhm.
really keeping it safe? Is it really good, clean air? And that's the question to be had. Because if you have a clean room, you don't have to worry about that.
Mhm.
Yeah, but it's still
But
no. It's very very good point. So I think it should be really addressed because it's a very common belief to
yes,
allow the leaks in order to because it makes sense. It will just blow everything out. Yeah, but okay.
exactly, exactly. And
And it's a
so
significant loss in
go ahead.
performance also. It might be significant loss in
Yes.
performance. Yeah.
Yes, and over the weekend, it was funny. There were some posts that started on LinkedIn, so I was engaging in some of the conversation about open blowing and leaks. And it's interesting because we also find, and again, we've done hundreds to thousands of air leak detection for a lot of our clients. So we find that open blowing is about 36% is accounted for of the compressor ability to perform. So we talk about CFM, about 36% of the total compressor CFM is lost to open blowing. And the highest we've seen has been 55% of compressed air, so total CFM being lost to air leaks in production facilities. And when you look at it, just the cost alone in that, you could calculate. The biggest one we've seen was a client had a compressor completely oversized, but they had leaks throughout the entire facility. I call it Polytube City because they have more polytube than any other manufacturer I've been at so far. And they had 130 horsepower worth of air leaks in their plant. So when you
Wow.
look at the cost of the asset and how long it takes to run that compressor, when you realize how much just by
Mhm.
fixing leaks, and that's the important part because leaks are one thing to quantify and find, and we do this all the time. We find different companies leak tags throughout the facility, which is an alarming to us when we walk and see that because that means that there's no follow through to actually fix the leaks. So you could quantify you have this much loss, but what are you doing to fix it? So that's the most important thing is not just finding them, but fixing the leaks to actually start saving the money to get cleaner air and then measuring what you're fixing to make sure it doesn't happen again. And if it does, because leaks will always come up, you have to be able to go in there and fix it right away.
Interesting.
Fascinating how many opportunities compressed air has, right? Like if you
Yeah.
combine
Yes.
leaks with the not correct design, the misuse of compressed air, the controls, and so on, and then you can run like on 20% of what you actually produce. So and
Yes.
or 30%. And
Yeah.
I always say that we need to see it as an opportunity. It is a chance. It's an opportunity. Don't blame yourself if your system is not running in an efficient way. Just
Yeah.
create it. Create this opportunity rather than the burden.
Yeah. Exactly.
Yes.
Just do something about it.
Yeah, so that's perfect. So I want to go, we're already at 16 minutes, which is insane. So I want to go into your process. So someone calls you, say, I want to do a leak detection. I'll put up a slide here
Yes.
to show. So what are we looking at here, and kind of what's your initial process, or how can people do this, or what can they expect when
Perfect.
someone comes in?
Yes. So I'd like to address the don't first, if I could do that. One of the don'ts, which happens a lot in the industry, and almost every client I spoke with, as far as leak detection, has stated that they do this. So the biggest don't: do not use soapy water to find air leaks, especially in food and beverage and in critical applications. Reason being, as we talked earlier, when you have an air leak, it also siphons. So when you're spraying water or soapy water to get the bubbles for the air leak, that soapy water is going into your process. So it's getting sucked through the piping, ending up on your product. Not an efficient way to do it. The picture you're looking at in the top left, there will always be telltale signs of leaks because there will be dark spots or whatever is in your environment because of the suction that happens from the air leak, the Venturi effect. It will end
Mhm.
up where on the leak. So you will see dark spots. You will see a buildup of whatever's in the environment, all the contaminants on that leak. And you'll be able to tell because if you have, let's say, dust, if you have, even in woodworking, we'll use that for example, sawdust, you'll be
Mhm.
able to see it, see all the sawdust built around the leak, but you'll be able to also see it float away. That's the fastest way to tell where there's a leak. There will be a lot of tail signs of it because of the dark
Mhm.
spots around it. The other way to do it is with leak detectors, and they're available. Customers could use them. They could hire, companies like us to go ahead and do the leak detection. So there's this leak detector that we use. It's made by CS Instrument. This is
Mhm.
a very user-friendly, or you could also use this leak detector as
Mhm.
well. So they serve the same purpose, but have they operate a little differently. So that's
Mhm.
another way to quantify your leaks. The other way we do it, aside from doing the leak detection with this, we put loggers on the compressed air system. So we do energy audits as well, because that tells you when there's leaks, especially when the production is really low. You could tell how the system is operating on that, with the energy audit. So you combine the leak detection with the energy audit. Then the other way to do it as well is with flow meters, which is the bottom right picture. So you insert flow meters and it tells you the flow within the system, and you could put it at multiple points. So you do flow
Mhm.
and pressure, and you could validate all the data and collect all the data. And then to quantify, you run all the reports. Thank God for a company like Direktin because they can run the simulation. So we'll send all the reports to Direktin. They simulate what happens when you fix the leaks, what happens if you were to, if there's a big section that needs to be replaced with piping, if you add a certain piping, if you add energy smart nozzles or blow nozzle or air knives, through the Direktin software, you're able to see how much money you're going to save, how fast you can save the money, and your quickest ROI on that. So
Mhm.
using all these tools is what's very beneficial for a lot of customers and how you could achieve energy efficiency, reliability, sustainability, reducing carbon footprint, and making more profit at the end of the day.
Yes, which is the ultimate end goal for all end users.
Correct. Correct.
Perfect. Elvira, do you have anything? I have one more image I want to share just because
Sure.
I like it. Just what are we looking at here? Because I think this is really cool. So this comes from the detector, correct?
Yes, that's from the leak detector. Those are live leaks we've performed at various facilities. And it'll show you. So that's one of the beauty of the leak detectors. You get to see the leaks. So it's one thing to hear them. It's another thing to see them. And through the leak detector, because it's ultrasonic, you're able to hear leaks that you normally can't with your normal ears. So
Mhm.
those silent leaks are the ones that add up and cost you a lot of money. And what you see in the picture, it's hard to see on the screen, but usually if you zoom in on the picture or if you download it from the leak reporter, you'll be able to see exactly where the leaks are, how much volume of air is lost, so in CFM, at what pressure, and how much that's costing you. And everybody has a different kilowatt hour rate, but you quantify all that and all the small leaks add up. We've recently did a project for a client where they thought they assumed there's like $5,000 worth of air leaks, and we found $76,000 that they were paying to the utility company just for running the compressor for having
Wow.
those air leaks, and we fixed them. Um, Another client saved $20,000 a month, which is that's our go-to story because the utility company came in and audited them because they thought they messed with their meter. They're like, you were spending this
Oh.
much, now you dropped $20,000 a month. What's going on? And it was just
Mhm.
through fixing air leaks. The ROI for that client was 3 weeks, and that's from us doing the leak detection to implementation, fixing everything.
Mhm.
Yeah, and their ROI was immediate. So these services do pay for themselves
Mhm.
very, very quick.
Amazing. Perfect. Well, we are a tiny bit over time. Elvira, do you have anything to wrap up
Yeah, I
or?
have anything. I think I have a low cost solution for leaks. Like if you don't have money to fire, it's a joke. It's a joke again. I say it's a joke. So if you don't have the money to hire any expert to buy a leak detector, well, a colleague of mine, it's not my joke. Unfortunately, I didn't come up with this, but a colleague of mine back in Germany told me, what if put the smell of the sausage in the compressed air and then put a cat in the facility and the cat will find all the leaks and will detect
Yeah.
it. I mean, poor animal again. I'm for animal protection, but I think it was like not a bad idea. But I saw
Yeah.
all the possible companies like this, and we can like have like the robot that goes and finds the leaks. But I'm like, no, like, you haven't been to all
Yeah.
facilities that look like a mess.
Yes.
Yes.
It's always better just to get an idea, like get really the first leak detection and the ROI in compressed air. It's so quick.
Mhm.
So it's really
Yeah.
such a low hanging fruit. It's so quick. You just have to be sure that you're in a good professional hands in
Mhm.
order to reduce the consumption and also improve the performance. Extremely important.
Mhm.
Correct. 100% correct.
Yes. Yes.
Yeah.
All right. Perfect. Well, I'm going to go ahead and wrap that up. If you have any questions or want to continue the conversation, Flavio's linked here. You can put any questions or comments in the comment section, and we'll monitor it for a little while and go from there. But thank you everyone for your time and have a great day.
Thank you, everybody.
Thanks everyone. Bye.